Hi and welcome to AudioTUTS.com. My name is Mo Volans, and in this screencast we're going to be taking a look at subtractive synthesis. I'm going to give you a guided tour around a pretty well-known subtractive synthesizer, and after a bit of thought and some suggestions from you guys, I've decided to use Subtractive from Reason. A lot of you will be familiar with the synth, and it's got a clear interface and everything I need to show you the basics of subtractive synthesis. In this session we're going to be looking at oscillators, filters and envelopes. I'm going to split the next session into another group which will look at LFOs, modulators and control mapping. Don't worry if you've not got Subtractive or Reason, because I'm going to show you the same sound that I'm going to build now in a few other synths. There's also some written tutorials on synthesis and building your own patches, so you can take a look at those as well in your own time. So let's get started, and first of all we'll take a look at the oscillator section. Now, oscillators are just the way synths make sound. They're their sound source. Every instrument has a sound source. For instance, guitars use string and pick, a trumpet will use a mouthpiece and tubing, a violin will use string and bow. Oscillators are just the way that synths create sound. In old analog instruments, the synth would simply make its oscillators from the electricity source, and you could alter the waveform from saw to square to sine wave, etc. And modern software synthesizers simply emulate this system. Now on the subtractor, we can see here that the waveform can be selected by simply pressing these arrow buttons. I'm going to use a saw wave to keep things simple. You can see that there's a phase control, an octave control, a semitone control and a fine-tune control. There's also frequency modulation and a mix control, so we can mix between oscillator number 1 and oscillator number 2. I'm going to turn off oscillator number 2 so we can just hear one oscillator working by itself. Now, as you can hear, it's pretty basic. It's just using one saw wave. The filter's fully open and our envelopes are all initialized. To make things a little more interesting, let's try adding a second oscillator. Again, I'll use a saw wave and I'll detune it slightly. Now, when we mix this second oscillator in, we should be able to hear a slight chorusing effect. This can give sounds more depth and make them more interesting. In this case, I'm going to try and create a pad sound, so this is going to be ideal. Let's have a listen to what that sounds like. And without the second oscillator. For this tutorial, I'm going to keep things simple and just use the two saw waves. With our two basic oscillators in place, we're ready to move on. Next, we're going to look at the filter section. A filter on a synth simply takes away harmonic content. In fact, anything we're going to use from this point, envelopes, LFOs, filters, are all going to subtract from the sound, hence subtractive synthesis. This filter is a multi-mode resonant filter, and as we can see, there's several modes here we can choose from: notch, high pass, band pass, and two different low pass modes. The numbers by the side of the modes simply show you the curve that they're using. The higher the number, the steeper the curve. Low-pass filters filter off the top end, allowing the low to pass through. High-pass filters filter off the low end, allowing the high to pass through. And a band-pass filter will filter a band, sweeping throughout the sound. A notch filter uses a small notch and is more like an EQ or phaser effect than a true filter effect, but can be useful in some circumstances. Let's have a listen to each one. This is a low-pass filter. Here's our band pass. And here's our high pass. As you can hear, the notch is more of an effect. Now we're going to use a low pass filter here and add some resonance. Simply put, resonance just adds extra harmonics to the sound and makes it richer and more interesting. Push it even further and you get that famous acid squeal. Push it all the way to the top and the filter will start to self-oscillate and create its own sound. We're going to use about 20–30% resonance. Now ideally we want the filter frequency to be moving and dynamic through the sound. We don't really want it to be static. We want it to be a little bit more interesting and involving. So this is where we have to move on to envelopes. Subtractive has 3 envelopes. It has a mod envelope, which can be assigned to any source, a filter envelope, which is obviously hardwired to the filter, and an amplitude envelope, which is hardwired to the volume. We're going to be looking at the filter envelope first and automating the cutoff frequency with the envelope. There's 4 elements in each of these envelopes: attack, decay, sustain and release. Attack designates the time in which the envelope takes to reach from 0 to its maximum volume. Decay designates the time in which it takes to fall from that max. And sustain designates the constant once the key is held. Release is the amount of time it takes to reach to 0 or fall to 0 after the key is released. In this tutorial we're just going to be using attack, sustain and release. I'll go into different configurations and the decay times in future tutorials. So let's dial in some amount, dial in some attack and some release. We should be able to hear the frequency rise with the attack time. Now currently the release has no action because the amplitude envelope release is at 0. Let's turn that up to match and hear what happens. We can also turn the attack of the amplitude envelope up to match the filter envelope. That's quite a nice sound for a string or pad sound, but currently we have the polyphony set to 1, which means it'll only play 1 note at a time, technically monophonic. So let's turn it up to say 16 in case we want to play some big chords and see if we can play a few notes at a time. It's starting to sound more and more like a pad or string patch now, and with a few more tweaks from the mod envelope, some LFO and some mod mapping, we should really get a nice sound. We'll look at those in the next tutorial, and in the meantime you can look at the text and the playback from this tutorial to see this sound created in a couple of other synthesizers.